Okay, hello class, welcome to lesson 3. So we're going to start actually looking at the skills. And so we've seen some word problems that require us to solve quadratics where we have like a line equal to a quadratic or a number equal to a quadratic or really just find zero equals a quadratic. So that's really going to be the focus of today is solving those types of problems, whether that quadratic is in standard form, vertex form, or factored form. Like how are you going to do that differently? And so like really what we're doing is solving quadratics, and we call this like finding the roots. And so roots, the word roots doesn't just imply like zeros. It also implies like when the quadratic hits an x value, say like when the ball hits a height of 15, or when the ball hits a straight line, like the skeet shooting question where the bullet hits the object in the air. So we're still going to be looking at the plan, and so that's part of this goal. But really today we're going to specifically talk about solving quadratics in factored form, vertex form, and standard form. We'll look at the quadratic formula today. We'll look at simplified radical form, something came up from last unit, and then solving quadratics that are equal to a line, and that's very similar to solving these kind of things. So as a warm-up, we're looking at these 3 questions, and so each of these are called finding roots, but like notice that like this one is equal to 5, and so it can look at a little bit differently than if it's looking at 0. And so and you solve it a bit differently. Sometimes it's a little bit more challenging if it's there. But the goal really is to get standard form when you have something like that, which you already have. And so these two in the middle, like the second and third one, are really what you want to actually solve. And if you have factored form or vertex form equal to 0, like it is actually solvable without getting standard form. And so we'll actually look at that right now. So for the first one, we're actually going to subtract 5, get a situation where you get 0 equals. Quadratic formula will work here, but like so we're gonna look at the quadratic formula. But if it factors, like that might be nicer. It's quicker, less room for error as well. So you just look at like 3x and x and -2 and 4 to get -8. And then when you check the middle, you see you get 12 minus 2 is 10. And so then if you have factored form, you can find the zeros because like you get zeros when 3x minus 2 equals 0 or x plus 4. And so the one on the right is a little bit easier. The left one, you've got to add 2 and divide by 3. Very similar to restrictions from Unit 2. And then x plus 4 equals 0, subtract 4 from both sides, x equals -4. So you actually get 2 answers for the zeros, or for when this parabola equals to 5 or this parabola equals to 0. The next one, some people are going to jump right to standard form and then try to factor it, but vertex form is actually a great form as well. And we saw these skills when we did the inverse. So you can actually solve for x just the way it is right now. So if we subtract 9 from both sides, divide -3 by both sides, take the plus minus square root, just leave it as root 3, then add 4 to both sides. You actually get 2 answers, 4 plus root 3 and 4 minus root 3. And with mixed radicals, we can just leave them like that. And the last one, you'll notice it doesn't actually factor, so we're going to actually use the quadratic formula. So the quadratic formula is something that we did in grade 10, but just as a reminder, here it is. So just walking through it, we've got -6 plus or minus the square root of 6 squared minus 4 times a times c, all over 2 times a. It's really important that you put everything over 2 times a, because like you want to make sure that you're doing the numerator first. And then what you could do is that all that stuff inside, so you don't end up writing the -6, the 2, and the -2 a whole bunch of times. You can figure out what that number is first, so it's just square root of 12. And then actually the square root of 12 will break down and we saw this in radicals, into root 4 root 3, which is 2 root 3. And when you sub that back in, you could actually divide everything by 2. And we divided by -2 just to get rid of those negative signs. You don't have to, but it just changes the -6 to a +3, the -4 to a +2, And this plus minus 2, it just changes it to kind of like minus plus 1. And so, but you still have 1 as a plus, 1 as a minus. So that's what it would look like with the mixed radicals, which isn't trivial. Like that's sort of a challenging step, but you can kind of just like walk through it. And it's with practice, like you can start to see, and that's really like a radical situation. Now in a word problem, you'd probably be okay, just go to decimals whenever you're ready. But in general, like if we're dealing with the abstract, we don't really know what the x represents, and so we're just hesitant to round, and so we try to get it as simple as possible. We got the golfer. So this was a problem we looked at before. How long is the ball in the air? And so that requires us to find the zeros. So we're going to find out when the height's 0, and then we can actually factor it. So we're going to factor out the -5 to make this thing smaller. And if the second part doesn't factor, then you can actually divide out the -5 because you have 0 there. And only because you have 0 there. You can't just get rid of it anytime. But we really just care about what makes t squared minus 8t minus 20 equal to 0. And so that's t minus 10, t plus 2. And so the answers are 10 and -2. So it's 10 seconds. And so you can see, like, if you do this in Desmos, the equation, you're going to see that the ball is going to hit the ground at 10 seconds. The -2 is back here. It still works for a parabola, but it doesn't make sense in terms of the application. Now the question is, like, what if you already completed the square? So say you had a question where you had to find the vertex and then find the zeros. And so, like, if you had something like this and you've already completed the square, so you just got to trust me that this is equivalent right now because we haven't completed the square yet. But if this is like your form, or is just given in a different form, you could still sub in 0, just like we saw in the warm-up. Subtract 180, divide by -5, get 36. And that's actually nice. We could take the square root, plus minus, and then add 4. So we get plus minus 6, and then add 4 to it. So we get t equals 10 and -2. So notice that, like, if you had this form given, you don't actually want to expand it out to get standard and then factor it or use the quadratic formula. Like, these steps here kind of flow from unit 1. We did the inverse of a quadratic where we had to solve for something there, and so it's really just solving, and you're allowed to do that. You're allowed to do this balancing step as long as you're in vertex form where there's only one t value. You can't do it in factored form or standard, but you can do it in vertex form. Okay. The -2 is what we call an extraneous root.